Hello students, welcome to this lecture number 8 on ionic equilibrium. In this lecture we will be going to discuss a very important thing in the salt of hydrolysis subject, that is the hydrolysis constant, degree of hydrolysis and the pH of the solutions, that is after the salt has been hydrolyzed. So let us write hydrolysis constant that is given by kH. Then we will discuss degree of hydrolysis that is H, and the pH of the solution. So three things we are going to discuss in this lecture. First, let us understand the hydrolysis constant. For a salt Ba which has been hydrolyzed and produce this acid and base. So by the law of equilibrium we can write the equilibrium constant is this, that is concentration of this acid and concentration of this base divided by concentration of salt and concentration of the H2. As H2O is in excess, so the H2O is in excess, so what is there? Now we can't take it as a constant. So we take this H2O constant in the constant equilibrium constant, and this will give us the hydrolysis constant, and this is given by this HA and BOH, and this is all are in the bracket, means that is a molarity of this particular species, mole concentration. Okay, now second thing, that degree of hydrolysis. Degree of hydrolysis is represented by H, and this is basically is the ratio of the number of moles dissociated, number of moles of salt has been hydrolyzed, number of moles of salt hydrolyzed divided by total number of moles taken. So this is the degree of hydrolysis, that is represented by H, number of moles hydrolyzed by total number of moles available, we have taken total numbers of moles taken. Okay, so now we understand what is hydrolysis constant, and this hydrolysis constant for different salt. We have already understood that salt can be from the weak acid, weak base, strong acid, weak base, and there is a different combinations we will try. But hydrolysis constant for the salt from that strong acid, strong base, it is not feasible, because all those salt will not going to be hydrolyzed, that we have discussed in our previous lecture. Okay, so first we will take the case of the strong acid and weak base. Okay, strong acid plus weak base. The salt from the strong acid and weak base. Suppose this is the salt, it has been hydrolyzed and it is going to produce this HA and BOH. HA is strong, so this we consider strong acid, and this we consider weak base. So we can write this equation B plus H2 so it will going to produce the BOH, which is weak, and H plus, that is a strong acid. So this is basically, we have already discussed cationic hydrolysis. So for this, hydrolysis constant will be this, KH is equal to, we can write BOH, concentration of weak base, plus H plus ion, concentration of H plus ion, and this is B plus. Okay. Now we are going to see the BOH dissociation constant, dissociation of this weak base, that has been written this way, B plus which OH minus. And here Kb is the dissociation constant of this weak base. We can write B plus and this OH minus divided by, that is BOH, concentration of the BOH. Right? Now if we take, this is the number 1 equation and this is the number 2 equation, and if we multiply 1 into 2, 1 equation and 2 equation, what we get, let's see, KH into KB, that we put this BOH plus H plus ion divided by B plus and B plus minus BOH. So what we get? We get a very important relationship, that will be the H plus and OH minus, means that is KW. So we get a very important relationship here, that is KH into KB is equal to KW. That is a very important relationship, and this relationship will be helpful in many numericals that we will see later on. Okay. Now we are this again, we are taking the hydrolysis of the salt equation, that is this, and BOH plus H plus. This is the relationship we get from the hydrolysis constant with its dissociation constant of the base, weak base, with the Kw. Now we will get a relationship, want to get a relationship between the concentration terms to know the degree of hydrolysis. So here, suppose concentration of, initial concentration of this B plus, that is the salt, is C, and initially there is no ions, right? After, suppose there is a degree of hydrolysis is H, then we can write CH into CH. So here again, dissociation constant we will find, that is CH into CH divided by C minus CH. This will get the CH square, because the C is cancelled out, and 1 minus H we will get this 1 minus H. 1 minus H we can neglect. We can neglect means we can assume it as a 1. Then we can say this will be this. Okay. So what we get here from this? We get the hydrolysis degree of hydrolysis by this equation Kh by C. Again, Kh we already know, that is Kw by Kb. So you will just put this Kh equal to Kb Kh. So we have put the Kh here. So what we get? Now Kb Kw by Kb into log C. Okay. Now we see here the hydrogen, we want to understand the pH. What would be the pH? pH for this minus log of hydrogen ion concentration, right? So we get hydrogen ion concentration CH. So that is minus log CH. And CH, we just put this value, we will get the minus log root over of Kw into divided by Kb, and the C will be here because that will be C into H. So now we simplify this, you will get this relationship, that is pH equal to half pKw minus half pKa plus log C. So half pKw at the temperature 25 degrees, that is 40. So this will be 7 minus half pKa, this will be pKb plus log C. This is a very, very important relationship between the pH and the Kb, dissociation constant of the base, and the your concentration of this. So we will get for this, when the salt produce the strong acid, at that time, if we know the dissociation constant of the weak base and we know its concentration, then we can easily able to say about its pH, and this will help us to understand many things. That will have some numericals that will give us a lot of information about this. So I think you understand how that from the strong acid weak base, the salt which is hydrolyzed and produce the strong acid and weak base, it is going to give this relationship pH equal to 7 minus half pKb plus log C. So from this relationship we will be able to calculate the pH of the strong base and weak acid from this, and for weak acid and weak base, that will be the difference between the base dissociation constant of the acid and the base. So accordingly this pH will determine for the weak acid and weak base. So we will make one example numerical that will give you much more clarity. This is one example that gives you much more clarity about this concept of this degree of hydrolysis and other things. That is, a weak acid HX has the dissociation constant of this 1 into 10 to the minus m. The weak acid dissociation constant of this, it forms, this is a dissociation constant, right? It forms a salt NaX on reaction with alkali. The degree of hydrolysis of 0.1 mole solution of the NaX will be this. For this, what we have to do first? We have to first, from this dissociation constant, you have to calculate the hydrolysis constant. After this, you calculate the hydrolysis constant from this relationship. This is the relation that we have already discussed, that Kh is equal to Kw by Ka. Ka is the dissociation constant of the weak acid. This is the weak acid, and from this we can get the hydrolysis constant. It is 10 to the power minus 14 divided by K is given here 10 to the power minus 5. So it will coming around 10 to the power minus 9. So KH is here 10 to the power minus 9. Okay. Now we know, suppose this is a salt. This salt has been hydrolyzed and it is we are directly going to the, okay, this will produce the Na. When it is hydrolyzed, that is a weak acid and it will produce a strong base. So for this solution we will get NaOH plus HX. HX with the weak acid and this will be strong base. Okay. So suppose this is a concentration. This is you will get this is 0 at this time. 0. Now we get, suppose degree of hydrolysis is H. So we get CH and CH. So the hydrolysis constant we can easily calculate here from here. That is KH is equal to, we can get CH into CH divided by C minus CH. So it will give CH square by this 1 minus H. You will assume 1 minus H as a 1, so we get the CH square. So from this we will get the hydrolysis. We will get the degree of hydrolysis is, this is the degree of hydrolysis H. So from this we will get, already we know the KH. So we put this value here. CH square is equal to 10 to the power minus 9. 10 to the power minus 9. Then the C value it is given here 0.1 mole to H square. So we will get here, we are taking this from here, that we will get here that CH square is equal to 10 to the power minus 9 and H square is 10 to the power minus 9 by C. C is given here 0.1. We will just put this 0.1, 10 to the power minus 9 by 0.1. It will be giving around 10 to the power minus 8. So we get the H is equal to 10 to the power minus 4. But we have to answer it in the percentage. So if we get the percentage into 100, it will be coming around 10 to the power minus 2. So what will be the right answer? Right answer will be the B. So in this way we can able to calculate. Sometimes it is, suppose you have to calculate degree of hydrolysis now. Sometimes you have to calculate, you have been given the degree of hydrolysis, then you have to calculate the pH also. That type of questions that you can see from your textbook and you can solve yourself, that you will much more confident about it. So that is all for today's lecture. In this lecture we have discussed the hydrolysis constant and the degree of hydrolysis and the pH for the different solutions, whether the salt is coming from your weak acid, strong base, strong acid, weak base, and the weak acid, weak base. Okay, I think that will be helpful. So thank you for seeing this video. Thank you very much, and if you like this video you can share to your friends. Thank you very much.